People are familiar with the phrase nanotechnology or nanoscience. Few people have a good conceptual understanding of how small a nanometer actually is. In today's demonstration, I'm going to be walking you through a couple visual representations of how small nanometer is to give you a better understanding of the scale of nanoscience. So my first prop right here is 1 meter. And a nanometer is actually 1/1000th of this meter. So you can see that I have here 1 meter, and 1/100th of that meter would be a centimeter, and 1/1000th of this meter would be a millimeter, which is the smallest marking between these hash marks, and a nanometer is actually 1/1000th of this meter. So the first activity is going to do with ordering a object with which we are normally familiar, which would be a monarch butterfly. And I have here 4 cards: a monarch butterfly, the fine structure of a wing, a butterfly wing, and scales on a wing. And so to order these from largest to smallest, as you would probably be able to do, you would start with the whole butterfly, then the butterfly wing, and then, although some people may not know whether the scales or the fine structure are smaller, it's actually the scales of the wing and then the fine structure of the wing. And as you can see, as I flip these over, the monarch butterfly is on the magnitude range of centimeters, whereas the butterfly wing deals with millimeters, the scales on the wing deal with micrometers, and the fine structure of a wing is on the scale of nanometers. Although it's important to note that this mark here denotes 500 nanometers, so even though this is a very tiny structure, it actually is quite large on the nano scale. In order to be able to see things on these different scales, scientists need to use different tools. So the next task, it has to do with matching different technologies with the image that you would need in order to be able to see them. So I have here in my hands an image of a light microscope, of an electron microscope, of the naked human eye, and of a magnifying glass. And again, we're going to be matching these in order from their ability to see a large structure to the smallest structure. So again, we have a human eye, which would logically come first, and then a magnifying glass, a light microscope, and an electron microscope comes finally. And as you can see, the human eye is able to clearly discern things up to 1/100th of a meter. So that correlates to the whole butterfly in this picture, which is in centimeters. With a magnifying glass, it's easy to be able to discern up to 1/1000th of a meter, or on the order of millimeters, which would be a close-up of a butterfly's wing. A light microscope can see up to 1/1,000,000th of a meter, which would be a micrometer, represented by the scales of the butterfly wing. And in this instance, we're able to see, with an electron microscope, we're able to see to 1/100000th of a meter, which, as we discussed earlier, is the nanometer. This is also able to be done in ordering sizes of a cell phone. So as you can see here, I have a cell phone, a computer processor, a portion of a circuit, and then a transistor. And these also go in the same order. Place these here. You can see that the cell phone obviously being the largest, then the computer processor, then the portion of a circuit, and finally the transistor also corresponds similarly to the butterfly on these scales of magnitude that we're